Hello students, so today we are start our 10th chapter, that is light, reflection and refraction. Students, as you already know that light is a form of energy which gives us the power of vision. In this chapter, we will study the phenomena of reflection and refraction using the property of light. In other words, straight line propagation. For this, we have to understand some points. Let us take one by one. First is a straight line propagation. As you already know that from your previous classes, light wave travels from one point to another point along a straight line. This traveling of light wave is known as straight line propagation. So, light wave travel from one point to another along a straight line, and this phenomena is known as straight line propagation. Next point is ray of light. So it is nothing but it is a line in the direction of movement of light. Okay, now the next is beam of light. It is a bunch of rays that is parallel beam. Suppose that we have placed a mirror over here. If we incident light on this mirror, it has a property to reflect back in the same medium. So this phenomena is known as reflection of light. If we draw a perpendicular on the mirror, this perpendicular is known as normal, and this ray is known as incident ray, and this will known as reflected ray. The angle between the incident ray and the normal is known as incident angle, and the angle between the normal and the reflected is known as reflected angle. Here there are two medium. One is glass medium, that is mirror, and another is air medium. Now let us recall the laws of reflection. The angle of incident is equal to the angle of reflection. First law is the angle of incident will be equal to angle of reflection, and the second law is the incident ray and the reflected ray and normal all lies in the same plane. Okay, incident ray, reflected ray and normal all lies in the in the same plane. Parameters of mirror. Suppose that this is a spherical mirror. As it is forms a part of a sphere, it has some center, and this center is known as center of curvature. Okay, here it is radius of this sphere. This, suppose that this is a C and this is P. Okay, this CP is known as radius of curvature. Okay, this point on the reflecting portion is known as pole of the mirror. Okay, the line joining the center of curvature and the pole, or center of curvature or the pole, is known as principal axis. And the size of the mirror from point M to N is known as aperture of mirror. Now let us take one part of this spherical mirror whose reflecting surface is curved inward. Okay, this will be the reflecting surface and this is the polish. It is curved inward towards the center. So this mirror will be known as concave mirror. Okay, let us take another part of the spherical mirror. If it is curved outward, so this will be the polish and this will be the reflecting surface. This will be known as convex mirror. Now what is principal focus? So here it is principal axis of this spherical mirror. This is pole and this is center of curvature. Suppose we have applied some light on this spherical mirror. After incident, it will bounce back in the same medium. It can be diverse, it can be converse. Suppose it is conversing. So if we incident this light, it will converse through this point, bounce back in this point. If we apply this light, it will bounce back like that. If we apply this light, this will bounce back. This will also bounce back. So this point is known as principal focus. So principal focus is nothing but the point on the principal axis where all the incidence light parallel to the principal axis converge or diverge after reflection through the mirror. So this will known as principal focus. Now what is focal length? The distance between the pole and the focus point. This distance is known as focal length. In this PF. Okay. Now we are going to study the formation of images by spherical mirror by drawing ray diagrams. For this we have to understand rules for obtaining images formed by the spherical mirror. For this, rule number 1 is a ray of light which is parallel to the principal axis of the mirror passes through its focus after reflection from the mirror. So it can be clearly seen that the ray light which is parallel to the principal axis of the mirror passes through its focus. Here a light passes through a principal axis of the mirror passes through the principal focus, and this is the first rule for the ray diagram. Rule number 2, a ray of light passing through the center of curvature is reflected back along the same path. So here we can easily see that the ray of light passing through the center of curvature is reflected back along the same path. A ray of light which is passing through the center of curvature will reflect it back in the same path. This happens because the incident rays fall on the mirror along the normal to the reflecting surface. This is the normal. Now, rule number 3. A ray passing through principal focus after reflection it becomes parallel to the principal axis. So here we can easily see that a ray passing through the principal focus will bounce back parallel to the principal axis. Okay. Rule number 4. The incident and reflected rays follow the laws of reflection at the point of incidence. This point is P, making equal angles with the principal axis and principal axis, as you can see in diagrams. This is incident ray and this is reflected ray, and the angle of incident I, angle of reflected R, and this will be the normal. So while dealing with the reflection of light by spherical mirror, we shall follow a set of sign convection called the new Cartesian sign convection. Let us take x-axis as the principal axis is taken as the x-axis. Suppose this is a mirror. The convections are as follows. The object is always placed to the left of the mirror. Either it is concave mirror or convex mirror. Suppose this is a concave mirror. So object will always placed at the left side of the mirror, and the height of the object will be h, and all the distances parallel to the principal axis are measured from the pole. All the distances measured to the right of the origin are taken as positive, and all the distances measured to the left of the origin are taken as negative. Distance measured perpendicular to and above the principal axis along y-axis are taken as positive, and all the distances measured perpendicular to the principal axis and below the principal axis are taken as negative.